All right, so I'm going to go through the test review for y'all. Your test will be probably on Monday. That's what I'm thinking for your test. But since I'm not able to be there in person in order to help y'all with going through the test review, I did want to record myself working through the test review. So if you do have any questions after these videos that you watched in class today, feel free to shoot me an email if there's still something that is not making sense. But let's go ahead and get straight into it, okay? So Unit 5 has been all about triangles. So 5.1 all the way through 5.6. So let's get started. So number one, name the sides of triangle FYT for which angle T is the included angle. Okay, so what it means right there. So angle T is the included angle. So that means that angle T is going to be the angle that we're going to be focusing in on. And when it says name the sides for which angle T is the included angle, another thing that this question is based on, another way we can reword this question is what two sides of the triangle are creating angle T? Okay, so which sides, excuse me, create angle T? That's what we're being asked here. So we've got three sides in a triangle. We've got side FT, side YT, and side FY. So which two are creating angle T? Well, those two sides are side FT and side YT. All right, let's look at number two. Number two, name all pairs of congruent parts, that being the sides and the angles in the triangles, if we're given this congruency statement, triangle RED is congruent to triangle BAG. Well, keep in mind, back in 5.2, when we talked about corresponding parts in congruent triangles, we had three sets of angles and three sets of sides. Now, to figure out what these angles and sides are that correspond to each other, we could draw our triangles and label them correctly and in the correct order and see it that way. But another way we can do it is if we just look at the statements and just read what we're given. Okay, so we know that in this statement right here, triangle RED, we know that there are 3 points in this triangle, and the points are R, E, and D. And what's more than that, we know that these are not only points, but they're also angles. So we have angle R, angle E, and angle D. Now, along with that, we've also got three angles in my other triangle, triangles B, A, and G. We got angles B, angle A, and angle G. And in order to know which of these angles are supposed to go along with each other, we're just going to look at the order that they wrote it in. So we have triangle RED, where R is the first letter, and triangle BAG, where B is the first letter. So they didn't just spell it in that way just for kicks and giggles. They did it in that way because angles R and angles B are corresponding to one another. Okay, in that same way, angle E corresponds to angle A, and angle D corresponds to angle G. And not only do they correspond, but they're also going to be congruent to each other. And so then we can also talk about the sides in the triangles. Well, the sides in the triangles, if we take the first two letters in each statement, so RE and BA, then we have a set of corresponding congruent sides. If we take the last two letters, ED and AG, then we have another set. And then if we take the first and last, RD and BG, then we have another set of corresponding sides. And again, if you're a little bit confused as to how it is that I'm actually seeing this, well, let's draw our triangles real quick, okay? So if I have two triangles here, I'll draw them above my picture. And I want to name them RED and BAG. Now keep in mind, when I do name them, I want to make sure that I name them in the correct order. So if I do RED like this, then according to my congruency statement here, I need to go BAG. So now looking at the two triangles here, angle R and angle B, those are both my top angles. E and A are both my left side angles. D and G are both my right side angles. And then I have side RE and side BA both on the left side, side ED and AG on the bottom, and side RD and BG on the right. All right, next up, number 3. Write a congruent statement for the pair of triangles represented by side ML is congruent to side FR, angle L is congruent to angle R, and then TL is congruent to VR. So we want to write a congruent statement, which again, the congruent statement is going to look something like this. Okay, so up here at number 2, triangle RED is congruent to triangle BAG. That was one of my congruent statements. So I want to write another congruent statement, but this time I've given a description first. So up here they gave me the congruent statement and then asked me to figure out all these other statements. Here they give me a few of the other statements and want me to piece together the actual congruent statement. So what I'm going to do is I'm actually going to start by drawing my triangles. Okay, so I'm going to draw two pretty decently congruent triangles. And what I'm going to do is I'm going to label the parts as I see them pop up in the description. Okay, so I've got side ML is congruent to side FR. So I know in one of my triangles I need to have side ML, and in the other triangle I need to have side FR. Well, I also know that angle L needs to be congruent to angle R. Okay, well, I've already got those two in place. And again, we can go ahead and mark these things as well. So it says side ML and FR, so I can put one tick on both of those. And then angle L and angle R. And then the last bit is TL and VR. Well, in order for me to have side TL, I need to add point T to my left triangle so that I can have side TL. So likewise here, if I want to have side VR, I need to add V to the triangle that is going to have R already in it. And so now I can kind of see what my two triangles look like, how they're supposed to be labeled. And so now I can write a congruent statement in order to show their corresponding parts lined up. Now keep in mind with this congruent statement that there's actually 6 different ways that you can write the congruent statement. Okay, I'm not necessarily going to be looking for any one correct way. I am going to be looking for one of the 6 correct ways. Okay, so as long as the corresponding parts are all matching up, that's going to sound great to me. So one example that you could have is you have triangle MLT is congruent to triangle FRV. Okay, and that would be if you start at the top, go to the bottom left, and then go to the right when you name them. But again, that's not the only way that you could name these. Okay, you could also, if you wanted to, you could say triangle LMT is congruent to triangle RFV. So this time, if you went left, up, down, then you could name it that way. But with either one, you have a congruency statement. And again, there's 4 other options you could have as well. Okay, so let's next look at number 4. So number 4, we need to find the measure of the numbered angles. So the numbered angles in questions are angles 3 and 4. So first up, we are looking for angle 3. So we need to figure out, so given these two angles right here, a 72-degree angle and a 53-degree angle, we need to figure out angle 3. Well, I know that if I take angle 3 and I add it to the 72-degree angle, then that's going to overall equal 180 degrees. And this is because angle 3 and 72-degree angle, they make a linear pair. Okay, they're two angles that are right next to each other that line on a straight line. So if I want to solve for angle 3, I'm going to subtract 72 from 180 so I can get that angle 3 alone. And so I'll get that angle 3 has a measure of 108 degrees. Next up, I want to figure out angle 4. Well, we talked about this one theorem back all the way in 5.1 called the exterior angle theorem, which told me that angle 4 right here is an exterior angle. So this exterior angle is going to be equal to the sum of the two remote interior angles. Okay? And another way to think of the two remote interior angles is if you look inside the triangle, okay, you got 3 angles, this angle, and then this angle, which they didn't label for us. Okay? So the two remote interior angles are the two that are away from the exterior angle in question. Okay, so with angle 4, it's touching this interior angle. So I don't want to use that one. I instead want to use the two angles that it is not touching. So exterior angle theorem tells me that angle 4 will be equal to the sum of these two, 72 plus 53. So add them together and I'll get that angle 4 has a measure of 125 degrees. Now, granted, this is not the only way we could have solved this one. What you could have done instead, you could have tried to figure out what this missing angle was. So if we have 72 and 53 and we add them together, we get 125. And then according to triangle sum theorem, all of the angles inside of a triangle, the 72, the 53, and then this unknown angle, must add up to equal 180. So we could have done that and figured out that this angle is 55. And then to figure out angle 4, we could have done the same thing we did for angle 3. Angle 4 plus 55 would equal 180 because they make a linear pair. And we'd still get angle 4 is 125. So you'll see that with a lot of these, we can work them out multiple ways. Okay, let's look at the next one, number 5. So number 5, our instructions are merely to find x. So we're given this triangle has degree measures of 54 degrees, x plus 40 degrees, and 2x minus 5 degrees. Well, how can we figure out what x is? Well, we're given a triangle with 3 angle measures, okay? And 2 of those angle measures have x's involved in them. So how can we figure out what the x's are? Well, triangle sum theorem tells me that if I take each of these, 54, x plus 40, 2x minus 5, and I add them all together, I can set them equal to 180 because all the angles inside of a triangle have to be equal to 180. So now from here, I'm going to combine my like terms. X and 2x will give me 3x. 54 plus 40 will give me 94. 94 minus 5 will give me 89. So I've got 3x plus 89 is equal to 180. So to solve for x, subtract 89 over, and I'll get 3x is equal to 91. And then I'm going to divide by 3. And then right here, it's going to be a little bit of an uneven answer, but you can leave your answer either as 91 over 3, or you could approximate it to just being 30.3 roughly. Either way, that will be our answer for number 5. All right, let's next look at number 6. So number 6, in the figure below, MP bisects LQ at point N. Which additional piece of information would be enough to prove that triangle LMN is congruent to triangle QPN? So in section 5.3, we talked about the 5 congruency tests that we can use to determine if 2 triangles are congruent. So what they're giving us here, they give us one piece of information we know for a fact is true. MP bisects LQ at point N. Okay, so LQ, the L kind of got cut off there. So MP right here is bisecting LQ. Keep in mind, bisect means to cut in half. So then I know that this can happen, that LN and NQ are 2 segments that are equal to each other. Another thing that I can kind of pull from this, just kind of imply from it, is based off this picture, I know that I've got a set of vertical angles. So vertical angles right here and vertical angles right here. So those 2 things I have and I can take for sure are correct. That MP bisects LQ, thus give me 2 congruent segments, and we have a set of vertical angles. So now the question is, what additional piece of information would be enough for me to prove triangle LMN is congruent to triangle QPN? Well, we have to think back to our actual congruency test. Which ones are involving just a side and involve a side and an angle? Well, that tells me I could have side, I could have angle, side, angle, or I could have angle, angle, side. Okay, side, side, side wouldn't work because I don't need one of the angles, and hypotenuse leg wouldn't work because I can't really assume that these 2 triangles can be right triangles. So for this one, number 6, I'm really going to have 3 answers. Okay, so if I wanted for these 2 triangles to be congruent by side, angle, side, then that would mean that I would need another set of sides, okay? And more specifically, for it to be side, angle, side, I would need to know that the 2 sides that create the angle would have to be congruent. So for me to have side, angle, side congruence, I would need MN to be congruent to PN, because then that would give me side, angle, side. For me to have angle, side, angle, I would need to have 2 angles and then the side that is on the same side as those 2 angles. So for me to have angle, side, angle, I would need to know that basically angle L is congruent to angle Q. And then for me to have angle, angle, side congruency, I would need to have the other set of angles basically. So angles M and angles P.